a bit more. Okay, so on this 4-3, we didn't quite finish up 4-3 last time. So I'm going to start by going over these calculator problems because you actually need this when you're doing these applications. And we'll finish up this section with a couple of applications, all right? So the first thing is, if you look at this statement, what you're doing is you're finding an angle. So we're kind of doing everything in reverse. And in this particular problem, they say they want this to be in degrees. So what you're really doing is this. So on this number 20, it turns out what you do, and we'll talk about this a little bit more in detail a little bit later in the semester, but what you do is the opposite of the sine is called the inverse sine. So you're going to do inverse sine of 0.8659. You're going to do this on your calculator. That's how you find the angle. So the first thing is you'd want to be sure you check your mode. So the mode needs to be degree mode. You know, everything you do pretty much in this section is mostly degrees. So I want to be in degree mode. Then what you do is you go second sine. That opens up the inverse sine. So we go inverse sine, then you put in the 0.8659. Okay, like this, and then that'll give you the answer in degrees. Okay, so what we'll do is we'll just round that off to like 59 degrees like this. You could say this is like 59. If you rounded it to the nearest degree, that would actually go up to 60 degrees. Now, I want to show you this also because this is sometimes useful. If you have this on your calculator, you could also go to this angle applet. So if you go second angle, and then if you do the DMS, what that'll do is that'll convert it to degrees, minutes, and seconds. If you ever need to do that, sometimes you do, you can just convert that to degrees, minutes, and seconds. Then you've got that answer like that. But these were just rounding to the nearest degree, okay? All right, the next one, what you would do is on 21, you would just do theta is inverse cosine, and then put in the 0.2286, and then we'll just round that off, okay? All right, so inverse cosine 0.2286 is going to give me about 76.78. So that would round up to the nearest degree to about 77 degrees. Okay, so that's how you do that. So anytime you're trying to find an angle, you're doing the inverse trig function. And then the next one, I'll just put this in the calculator. You just go inverse tangent and then put in the 13.2894. Okay, and that would be 85.6. So on that, if we round that to the nearest degree, that would go up to 86 degrees. Okay, now, so you're going to do this sometimes if you're looking for an angle in some of these word problems. That's the reason I wanted to go through that. Okay, everybody with me there? Okay, so the thing that you're doing with this is, like if you were doing the sine of 90 degrees, if you know the angle and you're finding the sine, well, then you just put it in like that. But if you're trying to find the angle, given the ratio that's on the unit circle, then you're going to use the inverse. That's the idea, okay? All right, so let's go to this next problem. Let's see if we can set this up. So this one says, yeah, go ahead.
22, don't we have to find it in radians?
Oh, okay. It's a good idea to always read the directions, isn't it? Thank you for reading the directions, okay? Yeah, let's do what he's saying there. Okay, so what you'd need to do on this is you would want to go to radian mode. Okay, yeah, you put your calculator in radian mode, and then you just do the same thing. Thanks for pointing that out. So that's second tangent, and then 13.2894, and then that'll give this answer in radians. Okay, so in this case, let's just round this. This says round to 3 decimals, so in radians, that's 1.496 if you round that off to 3 decimals, okay? All right, everybody okay with what you did on your calculator? Be sure you're always paying attention to the mode that you're in. The next problem, we probably need to be back on degree mode, so I'm going to go ahead and put myself into degree mode here, okay? All right, let's see if we can get this set up now. So this says you're from a balloon 1,024 feet high. The angle of depression to the Ranger headquarters is 88 degrees 17 minutes. How far is the headquarters from a point on the ground directly below the balloon? Okay, so what you always try to do on this after you read this is try to find where your triangle is. All these problems have right triangles. So I'm going to just say, okay, this is my balloon. Okay, and that's 1,024 feet high. Okay, so I'm going to know that this piece right here is going to be 1,024 feet high like this. Okay, the thing that you got to make sure that you're really solid on is what's meant by angle of depression. So what we have is you have the ranger's headquarters. I'm going to put HQ for the headquarters. That's somewhere down on the ground. So your right triangle is going to kind of look like this. Okay, you've got that altitude of the balloon, you got the ranger headquarters over there. And then I'm going to go ahead and make the hypotenuse like that. All right, so that's what we're talking about. Now here's the part that sometimes students do not get right. So remember I said angle of depression means you're looking parallel to the ground and you're looking down at something. So it's the angle between here and there, like that. Okay, it's not that angle, it's the angle from there to there. So you want to draw a diagram on that so you know clearly what I'm talking about by that. So I'm just going to put a little dashed line there. That's what we call the line of sight that's parallel to the ground. And then the angle of depression is this angle. So that's what 88 degrees 17 minutes is. All right, everybody with me there? Okay. Now, it's real helpful when you're working with triangles that you know this from geometry. Sometimes students know it, sometimes students don't. But anytime you have two lines that are parallel, and if you just take a line that sort of slashes through it like this, then these two angles right here, this angle here and that angle there, those are called alternate interior angles, and they're always equal. Okay, do you remember that term from high school or somewhere? It comes in handy. There's more than one way to do this, but what you really have is the ground and line of sight are parallel. So if that's 88, so is that. So automatically you can do that. Now you could also figure out that little angle there by subtracting from 90, right? Okay, so you can do that either way, but it's nice to know that interior angle. So what I'm going to do is just throw in right there, that angle is 88 degrees 17 minutes. Okay, so now what we have is we have our triangle, and we should have enough information to do this then. Okay, so what we're doing on this one is it says how far is the headquarters from a point on the ground directly below the balloon. So what that's meaning is you're looking for this distance right there. Okay, that's what that says. Okay, is there any question about the setup? Most of the time that's the hardest part of these problems for students is reading it and drawing your diagram. Is that clear? Yeah.
I don't understand why you said the depression angle, but why is it up there?
Okay, because what you got to be clear on, and I'll go back to this diagram. We talked about this barely a little bit last time in class, but okay, you're looking parallel to the ground and you're looking down, so it's this angle here. A lot of times students want to think it's this angle, but it's always between your line of sight and whatever you're looking at, that angle right there. Everybody clear there? Okay. So also angle of elevation, you can see in that diagram if you forget. That's the key to the problem, really. Okay, now if we finish this up, what I'm going to do is I'm going to highlight what we have. Okay, we know this angle, we know this. You always have to know at least two parts of the triangle. So now we're going to do this. Okay, we got to match those things up. So what we learned last time is we learned that the sine is opposite over hypotenuse. We learned the cosine is adjacent over hypotenuse. And we learned the tangent is opposite over adjacent. And you want to use one of those three trig functions. Don't use the other three because you're going to have to do this on the calculator. So look at your angle and talk out what do you have. What is this? The side what? Opposite. What's that? Adjacent. So what are you going to use? Tangent, right? Okay? Because you want to focus on that angle, opposite, adjacent, like that. So you're going to use the tangent because that's the one that matches this. So what you want to write down then is we have the tangent of 88 degrees 17 minutes is equal to side opposite, which is 1,024, over adjacent, which is x like that. You now have an equation that you can solve, and you'll have to go to your calculator to do this. So you can do this kind of rearranging of the equation in your head, and if you cross multiply, and you don't have to write both of these steps because most of the time students pretty easily get to the point where they can kind of rearrange this in your head. So what you'd want to do now is divide both sides by the tangent of 88, 17. So I'm just showing that step so that you know what I'm doing there, hopefully. Okay, so that's what we get. is the way you ultimately find x is you want to take your calculator and you want to do 1024 divided by that tangent. So you want to be in degree mode, and you can do this along with me if you want to. Okay, so we're just going to go 1024 divided by tangent. Now I showed you two ways to put the minutes and seconds in there. The best way, the simplest way is 88. And what do you want to do with the 17 minutes? 17 over 60, right? That's the simplest way. It just means 88 plus a fractional part of a degree. Or you can look for those keys that I showed you. The degree, minutes, and second keys are on your calculator. So you can do that in one step. Then we can round that maybe to 1 decimal. I don't know what the word problem says, but I'm just going to round this to 30.7, and then that would be feet. Okay, so everything I think in this problem was in feet. It said to the nearest foot, so I guess we would take that actually to 31 feet. Okay, so there's your answer to your problem. Okay, you guys understand what I'm doing? Okay, all right. I think most of the problems in the pre-calc textbook are real straightforward. I think when I teach the regular trig class, there's a little bit more time to go a little bit further in depth, but we want to make sure you get the idea on this, right? Okay, let's set this next one up here, and then I've got an app that I want to open up that I got up from the internet today that I thought was kind of cool. So let's see, this one says a building 240 feet tall casts a 40-foot long shadow. So a lot of times I just sort of read a sentence, pause, and then just draw a diagram for that. So I've got, this is going to be my building. Okay, and that's going to be 240 feet tall. It's good to write your units so you don't forget about your units on that. Okay, then it's casting a 40-foot long shadow. Of course, what's happening is you got the sun up here. The sun is causing the shadow to be cast. So you have a shadow going out like this. And we'll say that that is 40 foot long like that. So we got those two pieces right there. Right? Then I can connect this, the hypotenuse, so I've got a right triangle like that. All right? Okay, so that's what I'm getting from there. Then what it says, a person stands at the end of the shadow and looks up to the top of the building. And it says, what is the angle of the person's eyes to the top of the building? That's an interesting problem. So I think I've got everything here. I've got the shadow here. And let's see, it says the person's eyes are 4 feet above the ground. Okay? So according to what I'm reading there is the person is at the end of the shadow. So they're right there. And the person is 4 foot tall. Here's my dude. Okay, that dude is 4 feet tall. Okay, and what's happening is it says they are looking up at the top of the building. Okay, so I'm going to put like a little kind of diagram up there. Now we're going to look at their line of sight, parallel to ground. So I'm kind of making that parallel. And then we're going to be looking up at the top like that. Okay, and let's see what I'm getting myself into here. So I think I've got everything. The person is in the shadow, looks up at the top of the building. What's the angle of the person's eyes to the top of the building? Yeah, I've got plenty of information to figure this out. Okay, so here's what you want to think about here. We have two right triangles. Okay, what we're looking for is this angle right there. So we need to be looking at this triangle here. Okay, let's see what we know on this. Okay, you know basically, what is this right here? 40. That's still 40. That doesn't change, right? How about this? Is that 240 or is it something else? 236. It's 240 less the 4, right? Okay. So again, you got to kind of see what you have in that triangle. So what it looks like I have here is this. It looks like I have this distance right here. That's still going to be 40. But this distance right here is going to be 240 minus 4. That's the person's height. So that's going to be 236. Okay, now I'm going to redraw this triangle because this is what matters in the problem, is I've got 236 feet there, got 40 feet there, and then theta is what we're trying to find. Okay, so again, what you want to do is you want to talk out what you have, and it can be any of the three trig functions. Just coincidentally on these problems, I didn't really pay attention to what I was doing on here. They all are going to turn out to be the same. All right, so what do you have? If you look at the angle, what do you have? Side what? Opposite side. So what is it? and tangent, okay? Now, it can be anything. Tangent shows up quite a bit, though. Okay, so let's just write down what we have. We have tangent of theta is equal to the side opposite, which is 236 over 40, okay? Now, when you put this in your calculator, you're finding the angle, so what are you going to do? I don't do tangent, I do what? Inverse tangent, right, okay? So if you need to write this down, write it down. You're going to do theta is the inverse tangent of 236 over 40, and we'll get the degree on that. This one, I think, said round to the 100th, which means 2 decimals. So I'm going to go inverse tangent 236 divided by 40, and that will end up being theta is 80.38 degrees. Okay, so that's your answer to your problem. Okay, so there's times on these problems you have to kind of look at the given information, and it may translate to a different triangle. There may be multiple steps on that. Okay, is that reasonable what I did? Okay, all right. So that's how this works out. I want to show you this thing. I have explained trig functions this way before, but I thought this applet does a good job at something. So I'll see what you think of it. Okay, this GeoGebra is a great website that's got all kinds of what we call applets that demonstrate concepts real well. So what I want to show you on this is what the sine ratio is. We've learned that the sine is that this angle is opposite over hypotenuse, right? Okay, but we've also learned the unit circle, so I want to show kind of how they relate to each other. So what's happening in this, and to me this is a real good way of showing this, is that what happens is since the sine is opposite over hypotenuse, if you take this opposite leg and move it there, the value of the sine of that angle is 0.3891. Does that make sense to you that this length is 38% of the hypotenuse? Is that logical? Usually teachers don't teach it that way, but that's what really a sine is it's going to be the value of this side in relation to the hypotenuse. So in that case, it's going to be a certain percentage. That's what it is. Does that make sense? Okay. All right. If I did this, and if I go through and do, you can kind of change these things around, I think a little bit on here, you can change that angle. So one of the things that happens on this is if I change this angle and make the angle bigger and look at that sine ratio, then that sine's getting bigger. So this is showing that the sine of 53 is 0.8063, just means the opposite leg is 80% of the hypotenuse. All right, is that reasonable? Okay, just tell me, I don't know. I haven't taught it this way very much, but I think it's a really cool way to teach this. Okay, so the other thing is if you do a cosine is adjacent over hypotenuse. So the cosine of 53 degrees on your calculator is 0.59. It just means the adjacent is 59% of the hypotenuse. That's the idea. Okay, it's a percentage, right? So that's the idea. Does that make any sense or help or confuse you or what? Yeah.
So if that one is 59%, what is the rest of the percentage?
The what?
The rest of the percentage. If it's like a percent, wouldn't it be like?
Well, it really wouldn't. It's going to be different, of course, for every trig function. But what's left over on that really doesn't have any bearing on what I'm trying to show you. The thing that's kind of worth showing on this too, possibly, I don't know if this thing will let this stretch all the way up to 90, but we could probably get pretty close to it. So like if I went over on here, I don't know if this will work or not. It would be cool if it would. Okay, so that's almost a 90-degree angle. So if you were to look at the sine on this, if you look at something, as you get closer to a 90-degree angle, what happens to the leg? It almost becomes the hypotenuse, right? So actually, the biggest value a sine ever hits is 1. And what that really means is at 90 degrees, the side opposite would be the same as the hypotenuse. Okay, that leftover percentage is just what it is. Okay, it's not really, it doesn't matter for what I'm trying to explain there. Okay, all right, so that's the idea, how that goes. That's just kind of a cool way I thought to look at that. All right, so let's go to